Again, I'm not opposed to using technology, but I want to see if I can maybe figure this out without using technology. And first I want to do is just a point of intersection. So 8 minus x cubed, cubics are difficult, 8 minus 4x. Well, looking at that, I'm going to subtract 8 from both sides and add x cubed to both sides. I'm going to factor it, and now I'm going to say x comes out, and then you get x squared minus 4. I'm going to continue to factor this. It's x plus 2, x minus 2. Right, so I got really, three places where this is going to intersect. And what I want to do is think back to what I did in Math 119, is graph this guy out now. And again, it's not easy, but I think I can handle it. And I'm looking at this and I'm wondering, what's the y-intercepts? What are the x-intercepts? If you're wondering what I'm talking about, this guy over here. So I'm going to say the y-intercept is 8. I'll put that over there. That's going to be 0, 8. All right, and then I'm looking for that x-intercept, and that's going to be at 2. It's right over here. Now, again, I'm going to say it's not going to be a terribly accurate curve, but let's take a look. I got some other points to consider over here. And the points I have to consider is where x is equal to 0. So the line, I'm going to do the line now. By the way, I only got 2 points on this thing over here. The 2 points I got is the ones listed over here. This point over here is going to be 2, 0. And that's in the cubic problem. I certainly know what a cubic looks like, but the bottom line is I'm not exactly sure of much else on it at this point. I'm not going to go through any calculus on it either. But 8 minus 4x, I know it has a y-intercept at 8, and the x would also intersect at 2. So I know that. So I know my line goes like this over here. All right. Now, by the way, the curve also intersects at minus 2. So I'm going to say, minus 2 is over here somewhere, and it's going to intersect there too. So let's put that down. So at minus 2. And what would that give me? Well, it's an intersects there, so I'm going to try to think about it. What would that look like? That would be, I did say minus 2, right? That's going to be 16. Let me just take a look at it again. Yeah, 16. Now I'm going to kind of draw the cubic through this. I'll use a different color maybe. Kind of an S-shaped curve over here. Not the best picture in the world, is it? All right, but now I'm going to keep reading it. Let me get my eraser out. Kind of done with this business over here. I think I get enough detail down there to actually understand the question. They do claim that x is greater than 0. So this is the region they're talking. Whoa, I did it again. This is the region they're talking about. That over there. And what are they going to do with that? You have to about the y-axis again, like this. I'm going to get my representative rectangle. And I think I'm at the stage for the problem. I don't think I need to write down like what the shell looks like. I can do this without putting a shell down. So I'm going to put this over here. And I'm going to say, whoops, I didn't mean to do that. Let's see. I'm going to start at 0. I'm going to go to 2. And part of working problems, you start to realize that they're kind of easy to set up once you get a visual of it. So it's going to be 2 pi x times, the upper curve is actually that cubic problem, which is 8 minus x cubed, minus the lower curve, which is that line. So minus 8, and minus a minus 4 is plus 4x dx. All right? Going to keep moving through this. And, maybe I should simplify the integrand a little bit. I know the 8's disappear because 8 minus 8 is 0, and you left off with 4x minus x cubed. Let me write that down for you. I keep doing that, don't I? Again, the 8 disappears and left off with 4x minus x cubed dx. All right, I'm going to pull out a 2 pi. This goes from 0 to 2. And it's going to be 4x squared minus x4 dx. All right, let me think about that for a second. I want to integrate now. So what do you get? You get 2 pi. That's going to be 4x cubed over 3 minus x5 over 5, 0 to 2. Let me keep moving through it. You're going to get 2 pi. There's going to be a 3 here. And then you get 4 times, well, 2 cubed is 8, so that's 32. Minus, well, 2 to the 5th power, that's going to be 32. 32 fifths. If I plug in 0, it's just going to be 0. So I'm not going to write that down now. So I'm going to common denominator. Which will be 15. And let's take a look. Well, you can get 5 times 32 minus 3 times 32. You may wonder I'm not multiplying that out because it might be easier to do it without multiplying it. This is 15. 5 times 32 minus 3 times 32 is 2 times 32. 2 times 32 is going to be 64. Let's keep moving. What are you going to get there? 128, because 2 times 64 is 128 pi over 15. Let's get the red pen out and see how we did. I see that. I got that. Let's see if we got the original integration, which is this thing over here. It's partially simplified, by the way. I think I did that. Let's take a look. 2 pi 0 to 2, 4x squared minus... Yep. Let's see if we got the antiderivative over here. And that's going to be 2 pi, 4x cubed over 3. Yeah, things are looking good. What's missing in the answer key is the arithmetic. Thank you.